Welcome to the lesson on basic trigonometry. Our objectives today are to review the three basic trigonometric ratios in a right triangle, as well as apply that to the coordinate plane. Below are some things you may have remembered studying. Here we have an acronym, SOHCAHTOA. We'll be looking at that to help you remember the basic ratios. Over here, these are some ratios that are applied to a right triangle, but in place of the hypotenuse, we have r, and we're going to be using that when we look at the coordinate plane. Let's look at some basic definitions. In a right triangle, the sine, cosine, and tangent of an angle are defined as the ratio of two sides. So that's all that those trigonometric ratios are just ratios. If we consider angle A here, if we want to find the sine from this angle A, we take the opposite side over the hypotenuse. Those are just lengths. If we want to find the cosine from this angle A, we take the adjacent side and divide it by the hypotenuse. And finally, the tangent is the opposite side divided by the adjacent. As I was saying before, you probably remembered the acronym SOHCAHTOA over here on the right. It's easy to remember the ratios if you remember this acronym. The the S stands for sine. And O stands for opposite, H for hypotenuse. And you can see that right here. With the C stands for cosine. And the A stands for adjacent, and the H the hypotenuse. Finally, T is tangent. And again, O is opposite, and A is adjacent. Now remember, the key thing is it depends on which angle you're coming from. So, in this example here, we were coming from angle A. But in this picture here, we are coming from this theta. In relation to this theta, the opposite side is always directly across, and the adjacent is always right next to it. The hypotenuse never changes. That's always the longest side of the right triangle. If you didn't have those ratios, make sure to go back and write those in your notes. Let's look at a couple of examples. In example 1, we want to find the sine, cosine, and tangent for angle A. So again, we're coming up from the top. I'll go ahead and highlight that. Pause the video and see if you can determine the sine and cosine and tangent coming from angle A. Okay, so remember that the sine, is opposite over hypotenuse. If we look at that, opposite from A is 3, and the hypotenuse is 5. Therefore, the sine of angle A is 3 over 5. That's the ratio. The cosine then would be adjacent over hypotenuse, and the adjacent is 4 over 5. Finally, tangent is just opposite over adjacent, so that would be 3 over 4. Now in example 2, we are coming from angle B. So we're coming from a different reference point. For angle B, we want to go ahead and find the sine, the cosine, and the tangent as well. In example 2, pause your video and see if you can determine those three trigonometric ratios. Let's look at the sine. Remember, sine is opposite over hypotenuse. The opposite from B is now 4, and the hypotenuse is still 5. For cosine, the adjacent is now 3, and the hypotenuse is still 5. Finally, with tangent, we have opposite over adjacent, so we have 4 over 3. So again, these trig functions are not that difficult. It's merely just coming from the right angle and identifying which side is opposite, which side is adjacent, and where is the hypotenuse. Now we're going to go ahead and take our trig ratios and apply them to the coordinate plane. We're going to see what happens when we have our right triangles in this coordinate plane. We'll watch a short video now.
How do you find the sine of 90 degrees? In this lesson, you will learn the sine, cosine, and tangent of angles in the coordinate plane by using your previous knowledge of right triangle geometry. Let's review right triangle geometry. You may recall the Pythagorean theorem, a squared plus b squared equals c squared, where c, the longest side of the right triangle, is called the hypotenuse, and the legs are a and b. You can use this identity to find a third side of a right triangle if you're given any two sides. In geometry, you learned that for a given acute angle, the legs are either adjacent or opposite the angle. You may have learned the acronym SOHCAHTOA to help remember that the sine of the angle is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Note that with this method, you would not be able to find the sine, cosine, or tangent of the 90-degree right angle, only the acute ones. In a previous lesson, you learned that in trigonometry, we measure angles in standard position. Now let's talk about a new way to think of sine, cosine, and tangent of our angle theta. We'll start by talking about the coordinates of a point on the terminal ray, x and y. We can form a right triangle by connecting our point to the x-axis with a line. This triangle is called a reference triangle. The legs have a length of x and y. We'll call the hypotenuse r, because if we rotate the terminal ray, our point would trace out the path of a circle with a radius equal to the hypotenuse. From the Pythagorean theorem, x squared plus y squared is equal to r squared. And from SOHCAHTOA, sine, which is opposite over hypotenuse, is y over r. Cosine, adjacent over hypotenuse, is x over r. And tangent, opposite over adjacent, is y over x. Notice that y over x is also the slope of the terminal ray because it passes through the origin. As the terminal ray rotates, the point xy on the terminal ray moves, and the values of x and y change, but r does not. It remains a fixed distance from the origin and is always a positive length measure. Notice then that as the terminal ray rotates to become vertical, x has a length of 0 and y has a length equal to r. So how do you find the sine of 90 degrees? Use y over r instead of opposite over hypotenuse. Since at 90 degrees, y is equal to r, y over r is 1. So the sine of 90 degrees is 1. What would the cosine of 90 degrees be? Well, since at 90 degrees x is 0, the cosine, which is x over r, would be 0. You wouldn't have been able to do these calculations the old way with SOHCAHTOA. X, y, and r is better. By the way, we'll talk about the tangent of 90 degrees in another lesson. Now let's look at an example. If the terminal ray of an angle in standard position passes through the point 3, 4, find the sine and the cosine of the angle. Notice that we were given x and y. All we need is r, which is the hypotenuse of our reference triangle. You may recognize the 3, 4, 5 Pythagorean triple, but if not, you can find r using the Pythagorean theorem. 3 squared plus 4 squared is r squared, so r is 5. To find the trig ratios that the problem asks for, use y over r for sine and x over r for cosine. The sine is 4/5 and the cosine is 3/5.
Hopefully now you understand the relationship between r and the hypotenuse. We call this r when we're in the coordinate plane because this terminal angle, if it rotates, think about what it will look like. It'll make a complete circle. So r is truly the radius of that circle. Let's try one more example before we end. In this example, if the terminal ray of a point passes through this point, 5, 12, find the sine and cosine of the angle. Well, all we have to do is plot this point and draw a right triangle. So the point is at 5, which is here, and 12, which is up here. So if I draw my line, or I should say my terminal angle, it would look something like that. Now all I have to do is connect that down to make a right triangle. So here is my point 5, 12, right here. Let's go ahead and label what I know. The base of this triangle would then be 5. The height of this triangle would then be 12. In order to find r, I would need to use the Pythagorean theorem. So I can do 5 squared plus 12 squared to get me r. A squared plus b squared equals c squared. Simplifying this, I get 25 plus 144 will equal r squared. 169 equals r squared. Then I have to take the square root of both sides in order to solve for r. And in this case, I determine that r would then be 13. Now I'm ready to solve for or find the sine and cosine ratios. The sine, which we'll abbreviate as sin, the sine of this angle here, we'll call that theta, is then going to be equal to, if you remember, so opposite, which is 12, over my hypotenuse, which is 13. The cosine, abbreviated cos, of that angle is adjacent. Remember, that's the ka, so ka toa. So it's adjacent, which is 5, over the hypotenuse, which is 13. And that concludes our lesson in review on the basic trigonometry functions. At the end of this lesson now, you can identify those 3 basic trig functions, those ratios, in a right triangle. You should also remember SOHCAHTOA. And then finally, find the trig ratios of key angles in the coordinate plane.